Alright, fine, I'm math student. Today we will start with our module 2.1 day 2. It's on graphing absolute value. Content standard. Graph square root, cube root, and piecewise defined functions, including step function and absolute value functions. Language objective. Describe to a partner how to identify the vertex, the slope, and direction of the opening of the variety of absolute value functions. Okay, so for day 2, find the equation of the graph. So in this case, we will start out with identifying the domain, the range, and the vertical graph first, right? Okay, so we look at the graph. So in this point here, it's called the, let me change it to red, right? So this point here is called the vertex. So let that be v, so then be 1, comma 1. Okay, and to the domain of one function, that's the x direction. So if we choose an x here, we see the graph. Choose an x here, we see the graph. So then we see that the domain is all real numbers. So we write that, or we can write it using this notation for all real numbers. And the range is your y, right? So our y start from this point and going on up. So every time you see a y, there's also a graph, right? So it's including that point 1. So the y is including 1 all the way to positive infinity. Okay, so let me use a different color for our number 8. So the same thing for the vertex is this point here. So the vertex, say that it's a -2 and 3, and the domain, as we all know, is going to be all real numbers. Right. Okay, and the range is dependent where the graph. So the graph start from this point and it go all the way down. So your range will start at 3 to negative infinity. And I want you to understand is that notice how the range always start from where k is, right? So that's the vertex, and that's our 3. Okay, next one, so here is similar to number 1. We want to graph this function. Right? So from here, first list our parameter. So a is equal to 5, b is 1, and h is 3, and k is 0. Okay, so then there, a is a positive, so that we do not have a reflection. So first, so we know that list the vertex. So the vertex is OA, H, and K. So it can be 3 and 0. Right? So our transform point, so we start from 1, 1. We're going to go to xb plus h and ya plus k. Right? So then we see that will be 1 times b is 1 plus 3. Y is also 1 times a, 5 plus 0. So our point is going to be 4 and 5. The next point, -1 and 1. So -1 times 1 plus 3. 1 times 5 plus 0. So it's going to be 2 and 5. Okay, so first the vertex can be at 3, 0. So 3, 0 is this point. Right. And then the next point, 4, 5. So 4, 1, 2, 3, 4, 5. So this point. And then 2, 5. So then going to be this point here. So then our graph going to be this. Okay, and number 2, same thing. So we know that A is a -4, so it's going to be a reflection on the x-axis. Right? And B is 1, H is a -2, and K is a 5. So the vertex is -2 and 5. So we can graph the vertex first. So -2, 1, 2, 3, 4, 5. So we can have this point. Okay. So then we're going to transform 1, 1 to xb plus h and ya plus k. Right, so we can do 1 times 1 minus 2, 1 times a -4 plus 5. So we have a -1 and 1. And then -1, 1 will go to -1 times 1 minus 2, 1 times -4 plus 5. So this is going to be a -3 and 1. Okay, so -1, 1. Oops, I think I made a mistake on the vertex, so let me change that. Okay, so the vertex is -2, 5, so 1, 2, 3, 4, 5, so it's here. And then -1, 1, and -3, 1, so it's here. So then our graph gonna turn down. Okay, next one, it's the same thing here. So we view the transformation. So then our A is 1, and B is 7/5, H is 6, and K is 4. So then the vertex is going to be 6 and 4. So let's see. So then the vertex is going to go over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So we have a vertex here. Oh, I hate that font. Right. Okay. So then point 1, 1 will go to xb plus h and ya plus k. So we can do 1 times 7/5 plus 6 and 1 times 1 plus 4. So then this gives us 7 and 2/5, and this gives us a 6. -1, 1 go to -1 times 7/5 plus 6, and this is 1 times 1 plus 4. So the 6 minus, so then this gives us, so it should be 4 and 3/5, and this gives us a 6. So then 7, 6. So this I'm just going to approximate. So it's going to be somewhere here, and then 4 and 6. So we're going to approximate somewhere here. So our graph going to do this. Oh, I hate this function. Okay. So next one. Right, so similar to the previous one, so then A going to be 1, B is 3/7, H is 4, and K is 2. So the vertex is going to be 4, 2. So 1, 2, 3, 4, 2 is here. So our transform, same thing, xb plus h, ya plus k. So we have 1 times 3/7 plus 4, 1 times 1 plus 2. So this is 4 and 3, 7. And this gives us 3, -1, 1. So -1 times 3/7 plus 4. And this is 1 times 1 plus 2. So this is 4 minus 3/7. So this gives us 3 and 4, 7. Right? This gives us a 3. So then our graph be. So I'm just going to approximate 4, 3/7. So it's going to be somewhere here and here. So our graph can do this. Right? Okay. So my graph is small for me, it's hard for me to graph, but then when we were in class, we will give you graph paper, you guys will make a better graph. But then on all the tests, we will be looking for the vertex and the two transform points. Right. Okay. So far we have given you the function and you give it the graph. So now we will give you the graph and you have to give it the function. Right. So first I need to look at this point first. So then that's our vertex 2 and 5. But the vertex is set h and k. Right. So then our h equal to 2 and k equal to 5. Okay. Our next one is this point here. Right, so then remember we see that we have a point 1, 1, and we're going to transform into xb plus h, ya plus k is going to equal to 6, 6. So we say that 1 times b plus, well, we know that our h is 2 is going to be equal to 6. So now solve for b. So then b is equal to 4. Do the same thing for a. So then say that 1 times a, but a is given as 1. So 1 times 1 plus our k is 5 equal to 6. So 6 equal to 6. So then this is to check to make sure that we got it right. So to write our function, we said g of x and a is 1. Absolute value, and we're given that b is 4, so we said 1 over 4, parenthesis, x minus 2, close parenthesis, absolute value plus 5. Okay, number 8, okay, similar to the previous one, we're given the graph and we have to write the function. Notice that we're given that now b is 1. So this gives us our vertex. So the vertex is 1, 6. So then h equal to 1, k equal to 6. Right, and we're going to choose the next point. So next point, but notice how the point is on the left. So then our transform is going to be negative 1, 1, going to go to xb plus h, ya plus k is going to be equal to 0, 3. So then we said negative 1 times, in this case, b is 1, plus h is 1 equal to 0. So 0 equal to 0, so let's check. And 1 times a plus k is a 2 equal to 3. Right, so solve for a. So then a plus 2 equal to 3. So then our a equal to 1. Oh, okay, I just saw my mistake. My k is not 2, my k is 6. So I'm going to change that to a 6. And I'm going to change all of this into a 6. Okay, my mistake. So this is a 6, this is a 6. So then my a is going to be a negative 3. Okay, so we're expecting to be a negative because our graph is open down. Right, so our function g of x equal to negative 3 parentheses and b is 1, so 1 over 1 x minus 1 parentheses plus k is 6. Okay, well, that was my mistake. Right, so let's go on to the next one. Okay, so here they haven't given us what a is, what b is, so then we need to solve for a, b as well. Right, so we're looking at this point. So this point, our vertex, it seems like to be a negative 5 and negative 1. So x is going to be negative 5 and k is negative 1. And let's say we want to pick this point here, right? Okay, so that point, it looked like a negative 1 and a positive 5. So then it's to the right, so then we're going to transform from 1, 1 over to xb plus h, ya plus k. Okay, so we said xb plus h equal to negative 1. So our x is 1 times b minus 5 equal to -1. So b equal to positive 4. And 1 times a minus 1 equal to 5. So then a equal to 6. Right, so then our equation is going to be g of x equal to 6, absolute value of 1 over 4, x minus a negative 5, close parentheses, minus 1. But then that's a double negative, so it's going to become a plus. So 1 over 4, parentheses 1 plus 5 minus 1. Okay, and let's double check. So this point, I think I made another mistake. So this point should be a negative 2 and 5, not 1. So let me change this to a negative 2. So this is going to be a 3. So then let me erase this one and erase that. So it's going to be 1 over 3 and 1 over 3. Okay, so far we have 2 mistakes already, right? So you don't make mistake. Okay, let's go on to our next one. Okay, so say that 2 students are passing a ball back and forth, allowing it to bounce once between them. If one student passes the ball from a height of 1.4 meter and it bounces 3 meters away from the student, where should the second student stand to catch the ball at a height of 1.2 meter? Assume the path of the ball is linear over this short distance. Okay, so it's help if we draw our graph. So let's say one student gonna stand here, right? So that student is 1.4 meter and bounces the ball, so this 3 meters away. So let's say that we start from 0, 0. Okay, so then this, and then another student gonna stand here 1.2 meter, and we're going to find out where should that student stand, right? So when we look at our graph, it looks like our absolute value graph, but then there's an easier way, right? So we can use what we have learned from triangle similarity. Okay, so assume that the student is standing straight, right? Standing straight, so then it's perpendicular to the ground, and there's another student standing straight perpendicular to the ground. So the 2 triangles are similar, so we can use proportion. So we can use 1.4 over 3 equal to 1.2 over x. And then use our cross product, so then 1.4x equal to 3 times 1.2. And then solve for x, so x equal to 3 times 1.2 over 1.4. So when we work this out, our x is going to be 2.571. Right? So then the total distance from one person to the next is going to be equal to 3 plus 2.571, so which gives us 5.571. Okay. Right, so that's the end of day 2. So you are to do your book work, and also that your HRW is due. Right? And we want you guys to copy down notes for 2.2 day 1. All right, guys, stay safe.